Hey, it's Mr. Lum again, and today we're going to be talking about the autoionization of water, or sometimes called the self-ionization of water. Now, what that means is that sometimes water will split apart and become H plus ion and OH minus ion. And before we talk really about that, let's figure out what some of this stuff means. Anyways, if something's an acid, all it means is that the concentration of H3O plus is greater than the concentration of OH minus. Neutral simply means the concentration of H3O plus is equal to that of OH minus, and base is the hydroxide ion is greater than the hydronium ion. Now, water, like I said earlier, sometimes splits apart and becomes H plus and OH minus. Now, this H plus always combines with another water and becomes H3O plus. So for our purposes, H plus is the same as H3O plus. It means roughly, means the same thing. Okay, so what I want to talk about is if we were to write a Keq formula for this equation right here, we would see that Keq, or we're going to call it, instead of Keq, we're going to call it Kw. Now, Kw equals, well, the concentration of H plus, or you can also write H3O plus, it's the same thing, times the concentration of OH minus. Now, you do not divide by this, because this is a liquid. So water is a liquid, aqueous, and aqueous. So Kw, again, I'm just going to write a little bit neater. Kw equals the concentration of H plus, or sometimes we can just say H3O plus, same thing, times the concentration of OH minus. Now, it's been found under test that at 25 degrees, that the concentration of H plus in pure water, so make sure to remember that this is pure water, the concentration of H plus at 25 degrees is 1.00 times 10 to the minus 7, and the concentration of OH minus is also the same. So, Kw, if I were to plug in these numbers, Kw would equal 1.00 times 10 to the minus 7 times 1.00 times 10 to the minus 7. And that means Kw equal 1.00 times 10 to the minus 14. Okay? So these are three numbers that you need to keep in mind all the time. Now, let's talk about some of these things right here. So make sure to write this number down, 1.00 times 10 to the minus 14. That is what your Kw equals at 25 degrees Celsius. Now let's talk about what happens if water is heated. Okay. So if water is heated, if you have water that is higher than 25 degrees, what is going to happen to your H plus? Well, if water is heated, if this is now energy on this side, so we're adding more energy, so this is going to go, this is going to go up. So the amount of energy is going to go up, and therefore it's going to shift to the right. Okay, remembering Le Chatelier's principles, and it's going to go, so the energy is going to go up, it's going to shift to the right, and therefore if heat is added, so let's write this down, if heat is added, the concentration of H plus and the concentration of OH minus increase. Okay? So again, if heat is added, the concentration of H plus and OH minus increase. What happens to the new Kw when it's higher than 25 degrees? Well, Kw is greater than 1.00 times 10 to the 14th, because this number is bigger and this number is bigger, so therefore Kw also needs to be bigger. Now, if the H plus, here's another question you could get on a test. If water's heated and the H plus is increasing, okay, does the solution become acid, or does the solution become basic? Well, the answer is that the solution stays neutral, because remember, the concentration of H plus is still equal to the concentration of OH minus.